You're good to go.
All right, so a little bit about me. My name's Tyler Ford. I do quite a few different things, but currently right now I teach for the University of Utah Data Analytics course or boot camp. I am the architect of big data, machine learning, and data science for the University of Utah as well. I'm also the founder and starter of a company called Datauology that does consulting, data boot camps, trainings for a lot of the technical colleges around here. Before that, I've done some larger big data projects. I've trained Oracle on Kafka. I've trained Lyft on Kafka as well. I've been up to New York to help on the S-Phoenix project, which is particle accelerator. So roughly every time that runs, it was about 1 petabyte to 2 petabytes of data every time those sensors would spin off. I've trained medical groups on gRPC. I've done insurance companies as well. So I've done had my hands in quite a few different pots. I also serve as a subject matter expert for CompTIA on all their data certifications. So I fly out there a few times a year and help them update their content and create all the questions for anything on the data side of the world. So that's just a little bit about me. Got a lot of different certifications in different areas. I originally started out in SQL Server, and then gradually rolled into big data. So before any questions, or before we get started, any questions about Nifi, or does anyone have any experience, or has anyone looked at it before?
I used it a little bit in the past, but not anything deep dive.
Anyone else had any experience?
No, I haven't.
Okay.
I'm interested in it though. That's one.
Likewise, not me. So I'm looking forward to see what you have to show and tell here.
Let's kind of start walking through it. So Nifi. Hold on. So originally Nifi, let's start here. So this is kind of our roadmap. This is what we're going to look at. This was given in the outline. But what we're looking at is, and some of these are going to be demonstrations. Some of this is just lecturing. And so we're going to do a little bit of both worlds here. I find that kind of best to, you only lecture so much and then you just got to jump in. That's how the applications are. So kind of the history of Nifi. It actually originally started, the NSA started it, and they called it Niagara Files. I believe it started up in New York. And over time, they kind of saw the benefits and the use of it and rolled it out as an open source Apache project. It is still open source. It did get bought by a company, I want to say it was Annika, and then from there, Hortonworks bought it, and from Hortonworks, Cloudera bought them, and Cloudera and a few other people outside of Cloudera manage that code base. In all honesty, I'd say it's probably one of the most powerful open source tools out there. I did about 10 years in SSIS and about 5-6 years in Informatica, and there's things that I couldn't even have imagined trying to do, in all honesty. And so as far as like open source, it honestly, the power is pretty amazing, honestly. So some of the things kind of go over. So the user phrase, so it is a GUI, it is web-based. The user interface is I would say very simple. There's not a whole lot to it, which is, I would say, is a good thing. It's a drag and drop. You connect things and do a little bit of configuration, and it kind of picks up and goes. As far as security, you have your basic SSL. You can also set up encryption. It is a flow-based model, meaning there is no dependencies between things. So when you do set up things in a cluster, it is everything will be duplicated as far as every node in that cluster will have the same exact data because it is a shared nothing architecture. But because everything has access to the same data, it allows great load balancing and queuing and other things. And so that's where the performance and scalability comes in. So you do, when initially came out, you would hook into Zookeeper to handle the quorum management. They have shrink that down to have an internal piece now that'll do it. And so you get built-in load balancing, you get built-in queuing, and a couple other things that we're going to go a little bit deeper into. Also, to meet the audits, there is great power in the data provenance side of things, so you can see how data is changing over time, if it's getting manipulated, kind of the life cycle of data, what it's doing from beginning to end. Also setting up scheduling and what that looks like. Currently, as far as processors, so processors are something that either consumes data, stores data, or manipulates data. There's about 300 different processors out there. As far as data integration goes, I've yet to be stumped as far as getting a use case and not being able to deliver on it. So the integrations, yeah, I've yet to find one that you cannot meet the demand or the scalability, the integration requirements, or that kind of thing. Some things that really do stick out to me as far as the features and capabilities. So in the background here, this is what the user interface looks like, and we're gonna go into the actual interface after we go through some more of this, but this is what it looks like. You drag and drop your processors and you connect them, and you can set up retry logic. So if things fail, you get automatic built-in retries. And so just some of the things you get out of the box, really, they would usually require a lot of logic behind the scenes to get that kind of stuff right up built out of the get-go. So a couple things. So as far as the configurability for performance and scalability, you can set up, if you're wanting things to go faster, you can set thresholds to where you're okay with a little bit of loss, or you can guarantee delivery. You have options between latency or throughput. You can also set up prior, so you can do like LIFO or FIFO queuing. So if you want certain packets or certain data to get processed first, you can. We also have back pressuring. So as we set up these pipelines, if things way downstream are getting backed up, we can slow the amount of processes on them to let the things at the top of the pipeline catch up. And just some of those features are handy, especially when you're dealing with large data. When it's smaller things, sometimes you're not going to see as much benefit, but when you're into very large data, being able to get these out of the box is, to say the least, awesome. So kind of what a typical use case looks like is usually you'll have a data source of some sort. So you're going to fetch data. And you're not required to one set of data. You can bring in really as many types of data. So you could bring in a database, you could bring in Kafka, you could bring in multiple databases. So really, this is n numbers of data sources, but you'll do some sort of processing to it, whether that's a transformation, an enrichment, some sort of data wrangling, and then you can send that off to as many different data destinations as you want. Sometimes, if you were, right, so you can actually load up, like, say if you had certain AI models or ML models you wanted to load up, you can actually load those up in Nifi and run certain models on them, or even certain logs, and then send off certain types of data that were getting flagged off into like Elasticsearch for kind of more analysis, and then things that weren't getting flagged into Hadoop. But this is just kind of what a blueprint roughly looks like when you're doing a use case. Any questions so far on the stuff that we've gone over? I know sometimes I can get going a little too fast, but any questions so far on this?
Hi, I'm Hello. Sorry I didn't speak up earlier. What do
good.
you most, good evening. What do you mostly use this product for? Like, I'm trying to envision a project and how I would apply this technology. What are you guys using it for?
So we at the U, we use it pretty much for any ETL workflow you could imagine, whether that's pulling API data, pulling Canvas data. I've also helped ASU with their campus metabolism, pulling like IoT data. We also streamed cameras through some of this data. We can do prediction models. It really, the use cases are kind of endless, honestly. And if you have use cases in mind and would kind of like to see them, if you can drop them in chat, they're really not hard to spin up or show you what they look like in theory. So yeah, if you have some, drop them in and we can kind of walk through them, what that would look like. So.
Thank you. I don't at the moment, at least not readily, but I'm trying to keep up on technology. So a lot of acronyms that I didn't understand. I'm the beginner, so I'll be quiet mostly, but thanks for the info.
Yeah, you're good. So operating system, this is actually pretty universal. You can run it on Windows, which was Hortonworks made that possible. You can run it on Linux and you can run it on Mac. Java 21 is going to be the required version for Nifi 2. That's still kind of in beta. But Nifi 2 is going to be pushing a lot of Python. As far as hardware, I usually will do 64 gigs of memory CPU. I mean, I wouldn't say there's any requirement. I mean, obviously, a faster CPU is going to be better, but most of your server, any of your Xeons are probably going to be fine. But if you're doing virtual, I would probably do 6 cores. I was going to go the virtual route. If you really want to do some crazy type of analytics, you can hook in GPUs if you want to do like CUDA cores. And where disk, right, because this is really a processing platform, disk space is really just going to be dependent on how much data you're going to need to temporarily store while you're transforming it or using it. Some of the other things, specifically with software, if you want to hook into databases, you're probably going to need JDBC drivers. And if you want to play with different Hadoop components, some of them will require config, some won't. I mean, with Spark, you can use Livy, which is just like a REST API for Spark. But those are kind of the basic things. There's not a whole lot really required there. So what an installation looks like is pretty straightforward. Is you're going to download the Nifi package. You're going to extract it. You CD into it. There are some Nifi properties you may need to change, like your port, for example, and what file paths you want Nifi to use for like repositories and other things. And after that, you just run the start command and it will spin up. And you can access it by HTTPS localhost 8080/Nifi, and that's your default. And then you'll see a GUI spin up. So kind of walk you through what these UI components are. We have 4 main ones that we're going to look at. So we have a toolbar, we have the main canvas, we have our components and our status bar. So this in here is going to be our canvas. This is our toolbar, which kind of tells us about the processor or the active piece we're looking at. This is our navigation pane, which kind of shows you where in the data pipeline or in the group you're at. These are your different components that you drag and drop, and this is your status that shows you if there are any processors in error or how many components are currently running. If you have a cluster, how many nodes are currently in there and going, and other things like that. So next piece is we're going to start looking at, so we kind of talked about the processors. So what we're talking about specifically is up here, we will drag a processor down. So depending on what type of processor we want, we'll select it. We will right click on it, configure it. We'll set up our scheduling, and then we'll set up our relationships, kind of showing what we want it to do. Go ahead, Pat, you had your hand up there.
Yeah, there was a question in the chat, so let me read it off to you.
Go ahead.
What's the USP of Nifi, as I believe AWS Glue, ADF, Alteryx, RapidMiner, etc. all use similar use cases? Or a better question to ask, what sort of use case would be ideal to opt for Nifi?
Ideal use case. So we're going to kind of look at some of them. Yeah, I mean, there's so many different ways that you could approach that question there. I wouldn't say there's a specific one that it does better one over the other. Yeah. I mean, there are definitely some big data applications that are very, very niche and very specific. I would say Nifi is, in general, your limits are kind of endless as far as consuming data and what to do with it and how you want to approach it, save it, store it. And so we'll kind of look at more of those specifically.
One of the things too is that you could also be making sure it's understood that Nifi is also open source, meaning that your costs to it are really just your costs based on where you put it,
Right.
your boxes, your virtual machines, things like that. AWS Glue, some of these other products and stuff are things you pay for per transaction basis. So you have 2 different models of cost here, depending on what you're doing. So whichever works best for you.
Yeah, absolutely. I mean, there are costs. Right. So I have Nifi. This in this example is going to be running on my desktop. Right. It's open source, and it's really just the cost of just running on my desktop. So I'm not paying to use it or run it, or besides just playing around on my desktop. And so, I mean, there are costs. There are learning costs, right? Or sometimes you have to end up paying people to run it, but it's fairly intuitive. That I would say if you have done ETL work or data work, good majority of people can usually pick this up in about 2 or 3 days. Because as far as like the drag and drop and the UI, it's more of looking at what type of processors you're after and configuring more than trying to hack all the code. And so I'd say learning curve is actually fairly small compared to where if you're going to like Microsoft or Informatica, I would say the learning curve is quite a bit higher in those. But so that's how I would answer that question, but we're going to look more in it. And so these are, so when we're, I guess to kind of go back to, get back on going through this. So specifically, like our process we were kind of looking at, in this example, we have these different tags that you can kind of filter our different processors on. We're going to be using a different version than what I have in here, but as far as the layout, it's still going to be the same. So we have, in the older versions, we had about 300 different processors. That's gone up as the versions have gone, have increased. The latest version in version 1 is 1.23, but they are also moving over to version 2, which there are some good things going on in that version. A lot more Python is coming out in that one, and there are some more data sources coming out. Every time we have a processor set up, there are some base stats that we can see and some basic health information. So when a processor is running or has something configured incorrectly, it'll show up in kind of that warning sign. So when it's running, it'll be green. When it stopped, it'll be red. This also gives our version, our stats. So how many times it's ran, how long it's been executing, bytes in, bytes out, and also files in and files out. If there is an error on your processor, if you just hover over it, it'll give you a tooltip of what needs to be configured to kind of rectify that issue going on there. And every processor, it's the same across the board. Any processor you can right click on and you'll get this list. So you can view the data provenance of it. You can view the status. But the biggest one is going to be the configure to get to the properties. Also on your processor, this is where the load balancing and the scheduling comes in. You can set up timer driven cron. You can set up how many concurrent tasks, how many threads you want. If you have a cluster, you can tell it what nodes you want it to run on. Each processor has some optional properties and some are required. Anything bold is going to be required. Anything light is optional. So let's start looking at some of this and show you what it looks like. So what Nifi is, and these are some of the demos that we're going to look at. So this is what the canvas is, and this is running on my desktop. And so to kind of give you an idea, I've put these in different groups to kind of look at them, what they would look like. But for example, this is an API group that I stood up, and these are open data sets. And so what we have here is this is pulling a REST endpoint or basically an open data source. So what you do is and every processor has specific properties. But what you do is in this HTTP one, you set your method, you set your URL, you're setting your different timeouts, if we have authentication, cookies, all sorts of different properties. Every one is specific, but after that process runs or gets the data that it's after, it will dump it into a queue, and then that queue goes off to another processor. So, for example, I mean, we have access to any of these different processors. So we could enrich it, we could transform it, we could split it up, we could route it, we could look for duplicate data. So really, a lot of these are kind of looking through what they can do. I would also say Nifi is excellent with JSON, has lots of different things you can do with JSON. If, say, for example, this IP had, or this data had an IP, we could actually go out and get, like, go geotag it. If we had a latitude longitude, it can actually go out and look up like state and address data. So if we had those coordinates, we could go out and pull that. Some of these are sources. And then a lot of these are like things that can be modified. We can also do jolt transformations. And so really, that's one piece. So also Nifi can actually act as a web server. So you can do a lesson HTTP and allow Nifi to act as a REST endpoint to accept data. So you can actually create it as like a self-service analytics platform. So you could have a request come in, or you could set up specific requests and ports. So if they hit this endpoint, you could serve up specific data to them. So it doesn't have to always be an ETL tool. That's another piece that you can use it, and I've actually really liked that one. Because sometimes it's hard to figure out a way to, like, if you don't want to give direct access to a database, but you still want to let people consume the data, it's one way to easily create access and kind of limit exposure. There are a couple other things, like you have specifically, you can also, there are some other things with HTTP responses on how you want to handle them. So those are kind of what APIs would look like. If we're wanting to deal with SQL, these are some of the ones that I honestly are lifesavers to me. So if I have a massive database, I will use this one quite a bit. So what this will do is this will actually go in, look at the database, and give you all the database tables. And then you hook it into here. And this will actually create, so what this will do is this will generate all the select statements required to pull the table data. So say you had I don't know, 10 million rows in this table. This is going to create all the select statements with offsets. So if you only want to grab 1,000 rows at a time out of that database, you can. And then you do like an execute SQL.
Tyler, we're still seeing slides, so I'm not sure if you wanted to be showing your different screen.
Oh, hold on. Sorry. So
There you go. Yep.
yeah, sorry about that. But what I was saying is on this Nifi flow, is this is a common thing that we've done before, or we actually do quite a bit. We'll list the database tables. So if we have a massive database that we need to pull a bunch of data out of, we'll list out our different tables. We'll generate table fetch, usually like 10,000 rows at a time. And then from there, it'll go to execute SQL. And the cool thing about this is when this kicks off, if you have multiple nodes, each of these SQL statements will get distributed across each node. So you're going to have multiple connections going off. And it's going to handle all the paging and offsets. And that is a very useful tool that I've used quite a bit. Also, I really have liked this one. So it will, if you have JSON coming in, it will convert the JSON to SQL. So if you had a REST endpoint that returned out JSON and you want to take that JSON and convert it to like an SQL statement, like an update or insert or delete, it will convert that JSON on the fly for you. And so just these in and of themselves have been very, very, very powerful. The other piece that, as far as like simple file manipulation, these are kind of what those processors look like for manipulating files. So the one nice thing about like the get FTP is it will actually keep track of the files that are currently in the FTP. So if no new files are in that folder path, it won't kick off. So it is aware of what new files are going to be in there, or if nothing changes, it's not going to kick off. You can also do the same with the list file. So if you're connecting into like a file share, it will take basically hashes of all the files in there, and not necessarily just the file names. It'll hash them out. So if any of those files actually change over time, it will recognize them and kick that processor off again. And a lot of these are kind of stack on top of each other. So you have like your list file will usually stack to a fetch file, or you have a couple different options. That one is, so if you try to connect these and you're getting a red dot, it means it's a source and not a destination. And so those are kind of your typical file processors that you're going to use, specifically with processors. These are some other ones that I've used over time. They're actually pretty awesome, I would say. Specifically, you can listen to emails. So you can set up an email address and you can have Nifi look for specific emails. You can hook into WebSockets, which has actually been pretty nice for like specifically for like network security. I don't know if you do open data, but if you do have that option. You can hook it into IMAP, some more email stuff. TCP, you can actually look at ports and listen to ports. Consume Twitter. If you're doing SNMP traps, Kafka, Slack is really nice. So if a Slack message goes in, you can kick off a Nifi flow of some sort. And so really, it's hard to say like just one or two use cases because there's so much you can do in Nifi. So these are kind of some examples I gave. So you have the option to route things. So if a Nifi file or a file contains specific values, you can route them off. So, for example, if we had a flow file, say we had, say we were consuming data out of a database and people on that same data, but they wanted that data sent one wanted it sent in XML and one wanted it sent in JSON. What we would do is set up a specific route that would handle that data, but we would basically send that flow file to 2 different destinations and tag it accordingly. So, because you're going to handle JSON very differently than you're going to handle XML, but you have the option to do that kind of stuff. So you can also set up routes based on their actual content. So say you set up a regex and you notice some data, like for example, if you had sensitive, like this is a good one, if you have sensitive data that you flagged in your actual data, you would route that to like a sensitive data area or a sensitive data queue and have a do more processing specifically with it. That's just one use case, but you can do lots of different ones with it. You also can, you have the Nifi expression language, which is a whole other beast in and of itself. But basically what it is it's a dynamic language that you can set attributes in any of these processors. You can create specific attributes or variables to assign files and basically look for those variables and change them as you need to and route or manipulate them in some other way. So another thing that we've done quite a bit is doing the enrichment piece. But for example, if we have a database that we're looking at or pulling data, we can then use a record, or if we have specific ID in that database or data that came over, we could actually configure it or configure another service to go do some enrichment. So we could, like census data is a big one. So if we had that data, we could actually use the address in there to go pull census data or weather data. Basically, really any type of external API. If you had review data, you could go pull that. So you can also do, so again, we're the expression language, but you can do like specific, if the data formats aren't right, you can replace the content in them. This is kind of similar, but what we were looking at before, depending on their file type, we can route things to basically a specific queue depending on their file type. These are some other ones that are kind of, well, almost used on a continual basis, but this is a really handy one. You can actually use it to pull attachments out of emails. The query record is, depending on the type of data that's coming over, if it's like JSON or something, you can actually create SQL statements to query that data, the flow file that's coming over. You can convert records. So if you have a JSON or something along those lines, these are all your different options to convert it over. So you do have like Windows events, you have JSON, we have Grok, CSV, Avro, You have Excel. Basically, any type of data format you have coming over, you can then convert it to whatever format you want. So those are just some of the ones that I use quite a bit. But again, there's about 300 of them. So any questions on this that we're going over? I know it's a fire hose that we're going over, but any questions on how this looks or anything I can answer on it?
I had one question earlier on, you mentioned SSL and security. Does that just automatically get applied inside there whenever you're doing a pipeline, or is it something you kind of have to say on this one, I want it security, on this one, I don't, SSL sort of thing? What's the overall on that? Does it do it for everything?
So SSL is now default.
Okay.
So like even this just is encrypted. But on your APIs, depending on what type of API you're doing, if your API accepts it, like this one, I am doing HTTPS. There are certain ones that you can set up your own context service. But everything is encrypted now or behind SSL.
Okay, good to know.
And you can even encrypt the data going from piece to piece. These are where the load balancing comes in. But like, yeah, so behind Nifi scene, there's all those settings, but you can encrypt all this data that's getting stored there temporarily while it's getting transformed. So yeah, there's all sorts of different ways you can secure this, encrypt it, and lock it down. The versions before didn't require it. It was kind of optional. In these newer versions, it's no longer optional. It's all enabled by default.
Okay, good to know.
I know we're kind of coming up on the hour here, but any questions or anything that anyone would want to look at a little bit deeper? A couple more slides, but I think we get probably better knowledge transfer on actually going over and hands-on stuff than going over slides the whole time. So I guess one other thing that is handy is, so in this data, is the data goes from queue to queue. You can actually go in and analyze each piece of data that's in here and look at it. So this is just JSON that I was pulling down like a test data source. And so you can actually inspect each piece of data as it comes through. You can replay each piece of data. You can look at your different attributes. And every processor will either add specific attributes to these, or you can again add them with as processors. You have options to make them dynamic. So any questions I can help answer here before we wrap up? I know we got a lot going on here, but
Looks like Catherine's got her hand up.
go ahead, Catherine.
I'm curious for larger complex projects if there's any etiquette as far as making it readable, because we've got this large space where we can add all types of different boxes, all types of relationships. And I really appreciate this navigate section off to the side that shows you sort of where you are in the overall map. But just the same with code where we leave comments so that another person could come back and really make sense of it easily. Is there any etiquette that you're following as you're putting these together?
Yeah, so for example, you create process groups. So they're kind of nested groups. So right here, this is a process group, right? So like, for example, we'll usually have like dev or prod in like a parent group. And then each parent group, we will do what project this is on. So for example, say this was dev, this would be like the Canvas data. And basically, so it would go like prod Canvas, and then you're going to go in here and add your different processors. So let's see, get HTTP. So what you're gonna do is that, and then you add like a label behind it, what it's actually doing, what its purpose is. And then,
Yeah, I remember those from earlier.
and so you're kind of just walking through what it's doing, what its purpose is, if it's going to other processors, kind of what the idea is. You also do have version control. So on your different pieces here, so you can enable different versions, which is kind of very interesting. So if workflows are changing over time, you can actually snapshot them to specific versions. So you can always roll back if things are not working as they originally were. You can look at things that have changed over time. So that's kind of the etiquette behind it. You can also change colors. So, right, I mean, if you want to do like more critical ones or sources certain colors, you can. If they're like enrichment, you could set them up a little bit differently. So there are some things you can do. But obviously leaving notes is definitely a big one. It's kind of like leaving notes in code. Where are you going now? It should be going. Oh, finally. But like if it's a critical one, usually be red. If it's like a destination or if these things that are like critical workflows, you could color them differently, but you still want to leave notes. But you can also set up alerts. So say if this did fail, like this is a critical workflow, put email. So basically what happens here is on this, if this workflow failed, what you would do is it was a failure. You would then set this off to send you off an email. So that's one path it can take. If it was successful, obviously you're not going to kick this off, but you can also set it up to do like retries. So if this failure retries, you can have it go off you 5 or 6 times. And if it doesn't go off or work after those, then it will kick off an email so you're not getting spammed all the time. So there's a lot of configuration, a lot of power flexibility, and a lot of power behind this tool.
Super cool. Thank you.
Any other questions I can answer on this one?
I did kind of have like a general, just at the beginning, you were mentioning specs, it can be installed, seem like all OSs. Do you find that it performs better on one OS more than another?
Yeah, I would say Linux by far. But where you can, I mean, like I'm running on Docker, and if it's like a smaller amount of data, probably you're not going to notice it as much. But if you're doing large amounts of data, you're going to start to see the overhead quite a bit. Like on the camera data, we go through about what, maybe 2 terabytes a second. If we were going to try to do that on a Windows, I'm sure the latency would probably be so high up there that it wouldn't be feasible. Because I mean, you're going back to Java essentially, right? And there's just some overhead when you start doing Java on Windows. But I mean, it is possible to run this on Windows. And if it's smaller things, you're probably fine, but you can stick to Linux. I would say I like Red Hat and Ubuntu probably best out of all of them. I mean, all of them are going to run it, but I would say Red Hat probably has a couple other things that you can enable that make it a little bit better, like as far as on the latency side of things.
Great, thank you.
And yeah, I wish I could go through this whole thing because usually like Nifi is like 3-day course, 7-hour days. So it's kind of hard to condense all this into an hour. So I do apologize, but just kind of try to condense all the things that I use kind of on a daily basis and show you a high level what I do and what you can do with it. But yeah, I encourage you to go check it out. And I just installed like Docker desktop on Windows and spun up, download the image, and away I went. So it's maybe 5-10 minutes to get downloads set up and installed, and you can play around in it. You're not really having to hack all these different things apart to make it work. It really, out of the box, it's pretty straightforward and easy to use.
Great. Thanks, Tyler. Appreciate it. Any final questions anybody's got?
Like to express gratitude. Thank you so much.
You are
Yep.
very welcome.
Yep. All right. Well, thanks everybody. Really appreciate everybody coming. As always, I'll post this in the meetup that it's going to be on YouTube. It's just on the Utah Geek Events channel. If you search Utah Geek Events on YouTube, you'll find it, and should be up there probably tomorrow. Thanks everybody. Appreciate you coming.
Appreciate you, Pat. Tyler.
Thanks.
Thanks.
See ya.
Yep, you're welcome.